So, as I was saying, let us try to solve question number 6 over here, which relates to finding the energies. Okay. So, you can look at the question and you can attempt it. Okay. And meanwhile, I will also try to solve it. Okay. Yes. So, now, again, at least now, instead of just what you call just listening to what I'm speaking, you can actually give me some suggestions how to start. Okay. So I'm opening a Excel sheet. Okay. So we need some calculation platform. Either you can use hand calculation, calculator, computer, whatever, MATLAB or Python or anything. I'm just for the sake of convenience. I'm using a spreadsheet. Okay. So let us start with E1. Okay. So I want to find E1. Okay. What is E1? On the right, you can see the question: energy released by burning 28 liters of petrol. So here I will say liters of petrol. I'll enter 28 as the constant. Then per liter. So here you can see, assume 1 liter of petrol releases 3.2. So 3.2 E7. I hope it works. Yeah, it is working. So this is joules and this is in liters. Okay. So this is joules per liter. I'm just making the unit. So this is number, okay, or quantity, and this is unit. Now what is the next? Obviously, E1 equal to, right, energy E1 multiply, right? So I'm getting some number like this. Okay. So here you can only see two digits, 8.96 E plus 0.8. Okay. How do you see more digits if I want to see more digits? Because already it is in this kind of notation, right? So let us, so increasing the column didn't work. I know it would not work, but anyway, we'll just change the format. Okay. So see, right now I think it is in the scientific format. Rather than scientific format, I will select a regular number format. Okay. Okay. In this case, it will come like this because the this number itself, 3.2 E7 itself, have a lot of zeros in it. Anyway, so this is our E1. Okay. Now comes the interesting thing: finding E2. So how do we find E2? So on the right, if you see, let E2 represent energy in joules, a small particle having mass of 8. So M is 8 grams, 8 milligrams. Okay. Sorry, 9. So we in this formula E equal to mc square. What is the unit of? So E equal to mc square. Okay. So M should be in kgs. Okay. So this is in mass in mg milligrams. Okay. So mass will be whatever milligram is there. Divide by 1000 will become gram. Divide by further 1000, three more zeros, it will become kgs. C. Okay, what C is the speed of light. What is it? 3e8. Okay. So directly we can calculate now. E2 equal to m into c into c. Okay. So I'm getting something 8.1 into 10 to the power of 11. I can match the number format here, and it will match to something like this. Okay. Now, what I am interested is E1 is to E2. Okay, so that is what is asked in the question. Okay, so that means I simply divide. Okay, so because E1 in the place of E1, one is there. So divide both sides with value of E1. Okay, so then it will become so E1. Okay, so ratio. So what I will do is I'll take E2 and then divide with E1. Okay, so I'm getting something like this: 904 Actually, it's matching with one of the answers, but looks like some issue is there with the units. Huh? Huh? No, I think this is not that issue. So this is the in LaTeX it is correct only. It is like 9 lakh 4,000, whereas here it is 904. So whether it is really 904 or 9 lakh 4,000 is the thing that we need to just check. So this is meters per second, right? In C, should we take kilometers per second or meters per second? Meters per second only, and this one should be kgs. Okay. Then probably if I take this as 9 grams, then it will come correctly, match with one of the answers. Then where did I make the mistake? Okay, you tell me even value matching. What is your even value? That is where it is not matching. So let us see. I'll just copy this here. Matching. So which one? Where did I make a mistake? Then it will match. But did you take grams? He got without taking grams. He's saying. Okay. So now we just need to verify in E equal to mc square. Okay. What is the unit of m? Okay. So it should be in kgs only. Kg meters per second square. So energy is measured in joules, mass is measured in kilograms, and C is in meters per second. Okay. So we should take kgs. So if you take kgs, what happens? 904, right? So now what is interesting to have in the uh, what is interesting to have in the this thing question? Should we keep 9 milligrams or 9 grams here? Okay. So then if I make it 9 grams, then this will be G and this will become divided by 1000, and then our ratio will become 904. So this is the answer that is coming. So only thing that I need to do is remove the milli in the question. Okay. So this solves the first question. Okay, but then remember what was our objective? We had total 41 questions, and I want to make one more question, 42. Okay. What I found, I mean, obviously, what is the idea behind this? The idea behind this to show that even a small weight releases so much energy, something like that we want to say. So here, what I can ask the question in a different way. So after I prepare this question, then I got the idea. Why not ask the question in a different way? So what is the question asked in a different way? Is that uh, I can ask how many liters of petrol needs to be burnt to make it equal to this. Okay. So in this case what happens, we need to the answer will be like 28 or 28 point something like that. So rather than asking the ratio, we will say in order to generate equal amount of energy, how many liters of petrol needs to be burnt. Okay. Now so and to make the question a little more what you call see here it is little looks like more technical. Now, what will be the weight of a matchstick? Weight of a matchstick. In a matchbox, you will have matchstick, right? What will be the weight of a matchstick? So, idea is I will say that matchstick is having so and so weight. Now, the matchstick is completely converted to energy, and in the that is case one. Another case is that matchstick is used to burn petrol. How much petrol to release the same? So, something like that. I want to. I hope you got the comparison. Okay, so we'll ask. Okay. What is the weight of matchstick? So about zero point 0.1 gram. Full box of standard box of 35 matches can have mass of about 6.77. Okay, so zero point 0.1 gram. So zero point 0.1 again doesn't help much, but still we'll go with it. Okay, so what I will do now is I'll go here to one. Just a minute. So I'm just opening that file, and in that, if I go to the last, okay. So if I go to the last, so I hope you can see that here. So the mg is there, right? So that m I will remove. Okay. So by the way, here you cannot see the numbers. Okay, because we are doing parameterization. That's what those who attended last class will know. Anyway, so what the software will do is insert some numbers automatically. So earlier it was 28, now it became 25, and here it became 3 grams. And this one anyway, these two are constant, so it will remain same. So 25 and 3. Okay, so if I go back to my Excel, so in the place of 28, I give 25, and in the place of m here, if I give 3, the answer is coming around 3.37 something, which matches with the option B. So option B is the correct answer. Okay, so that is the benefit of doing it in Excel sheet. Okay, so now let's work on our new question. So what I will do, I'll copy this, and then we'll paste it. Just a minute. I'll try to increase the font zoom. Just a minute. So here you can see the seventh question came. So it is just repeating two times the same question. You can see the options here. So the second version, the new version of the question, I will edit now. So I think we don't even have to introduce E1, E2 here. Uh, let consider the weight of a matchstick to be uh, MW, matchstick weight, grams. Okay. So and we just saw one matchstick was zero point 0.1 gram. So we will try to give some value near to that. Okay. Uh, so completely converted according to Einstein. This part I will take. So sorry. I think we will just for the sake of language let E1 represent the energy in joules when this matchstick completely converted is how many same single word I think. How many liters of petrol need to be burned to release same amount of energy? Then this one will be there. Okay, so now I more or less completed this. So just see the question wording. Consider the weight of a matchstick to be mw grams. Let E1 represent the energy in joules, which is matches which this matchstick. Okay, energy released. See how difficult it is to make a question when this matchstick is completely converted according to Einstein's equation. How many? I think liters of petrol are needed to be burned to release the same amount of energy. So now, how do we answer this? I think. Uh, so can we combine into single rather than removing this rather than considering even? Needed that. Okay. So what I'll do, I'll just that will be released if so the just a minute. So I have to press Y here and P here. I made the amount of text little smaller. I think this sentence also I'll move. Yeah. Now we have the so the question starts with like this: how many liters of petrol are needed to be burned? Needed to be burnt, I think, to release the same amount of energy that will be released if the matchstick, if a matchstick, because I moved that sentence down, right? Okay, so again, I think you're all with me, right? So now we need to solve the question. Okay? So we have the question ready, and we need to solve it. Okay? So for solving, what we need to do is first we will try to give some number to this MW. So I'll just introduce that the parameter MW here, and we will give the value to that MW. So it can be anywhere from 1 to 9 milligram. What is that? 1 to 9 grams, but divide by 10. So it will be point something. So and then I'll just have to insert that in the last. So now if you see here, we are getting point 0.1. Okay. Now if I once again run this, so now it's coming point 0.5. Okay. So I think we'll do one thing. We'll make it two decimals. So from 10 to 90, here I'll divide by 100. So it will have two decimals. What happened? Yeah, so now 0.64, something like this, it's coming. So let's quickly solve it. So how do we solve it? So let's do the calculation. So here I will say E match. So energy from matchstick. Okay. I think already we calculated here. So MW. Say I'm going three lines above. I think I'll just copy from here. This is MC square. So MW grams converted into kgs. So this is kgs into this is C square. So C is 3 into 10 to the power of 8 to the power of 2. So E equal to mc square. So I got the energy from the matchstick. Okay. Now that one I need to divide. Uh, that one I need to divide by 3.2 E7 to get the petrol weight. Okay. So PET underscore W 3.2 E7. Okay. So PET underscore W is our final answer. Okay. So that answer for the question number 7 is the answer. So I'll just delete this and then find here PET underscore W is the answer. So units will not be rupees, units will be liters. and let's keep point one decimal. Okay. That the old one, anyway, it is because I had only six questions. See, this eighth one is just dummy, so it is like that. It is. I already had question seven. Now question eight we are not using. Actually, I can add one more question, so it is just not used thing. You your I got your doubt, but you understood what I answered, right? I need not copy because already it is there. So that's why one of the classes I was asking, how many of you do coding? Sorry, correct only. So I need one decimal. So this one is the correct answer. So what I'll do, I'll go here and put a new page so that this question will start coming from the new page. So no, this is sixth. Let's go to question number seven. Yeah. So finally we have the answers. I'll just, for the sake of this thing, I'll change. Oh, here I need to change with the option seven. So replace seven, replace seven, replace seven, replace seven. So now I'm waiting for the answers. Yeah. Okay. I don't need decimal. So because the number will be, I thought number will be small, but yeah, it is big. So here point zero f with comma, zero. Again, you may not understand exactly what I'm doing, but this is just formatting only. Okay, so now the correct choice comes to C. Okay. So you just need to verify this. Okay. So what I have to do now is the weight is 0.15 grams, right? So let's go to our Excel. Okay. So here instead of 3 grams, I will say 0.15 grams. Okay. So then the answer is coming to this one. Now, what was our answer in petrol? 421875. So the ratio is coming to 1. But then I don't know, I'm still getting doubt why thousands of liters of petrol is coming. Again, is it correct? Somewhere did I make a mistake? Okay. From milligrams we graduated to grams. So now it is fine. No, but it was grams before also, right? Huh? Eh, Huh? Okay. The ratio were also, yeah. It is also in the similar. Okay. Okay. Uh, but here, okay, the petrol was 19 liters. The ratio was big. Now the ratio became 1:1. The petrol became okay. In fact, that was my original. I see. I started with the idea. Now I am only thinking whether that. So now imagine the thing. What weighs only matchstick weighs only 0.15 gram, but to release that much of energy, lakhs of liters of petrol needs to be burnt. Okay, that conversion, whatever that relation, I want you to realize as a part of this course. So for that one question, okay, like that. So like that, in this there are other questions. Anyway, so now what I need to do is go back and remove that where I said which is correct. Yeah. So now you don't even know which is the correct answer because it is just we removed the indication, and that function which is there, generate nearby, again last time I told. So we wrote a one nice function, generate nearby. It will generate a nearby value to the correct value. So correct value is PET underscore W. It will generate a nearby value. Okay. So now I'll stop this video here and we'll go to another one. So let's